Welcome to part two. All right, so we're going to be looking at geometric sequences right now, and we want to write rules for those general geometric sequences. And so how do we do that? Well, first we're going to take a look at our sequence, try to find the ratio, and then use that to help us create our recursive rules. And remember, the recursive rule, what we just did earlier, we're trying to find out what do we need to multiply our previous number by to get the one that we're looking for, okay? So our geometric sequence is 6, 24, 96, 384, 1536, and on and on and on, okay? When we write that out in our numbers, they're just plain out numbers. When we write that algebraically, they're functions for n, or whatever number that we're looking for in the sequence, right? So function of 5 would give us an output right here. Function of 1 would be 6. The function of 2 would be 24. The function of 3 would be 96, right? So we're just going on and trying to figure out, okay, given whatever number we're looking for, whatever n, we're gonna find a number associated with that, right? So that's what these algebraic terms are for. The common ratio here is what number are we multiplying our previous number by to get the next one. Okay, so our previous one, 6, we multiply by 4 to get 24. Okay, when we're on our third sequence, what do we multiply our previous number by? 4 to get the next number in our sequence. So our common ratio is going to be 4 right here. Common ratio on this side is just going to be r. It's going by the next number. All right. So let's write a recursive rule. Well, for f of 1, the answer is 6. And when we have the function of n, that's going to equal n minus 1, our previous number, right, multiplied times 4, for any number where n is greater than 2. Here, given f1, okay, f of n equals the function of n minus 1 times r. Common ratio is r right here for any number where n is greater than 2. Okay, now that's a recursive rule. F times n minus 1, or I'm sorry, the function of n minus 1 times 4, that's going to give us our next number in our sequence. Here, we can write it how we did in the previous one where we just looked at exponents. So if we do that here, we have the function of n equals 6 times 4 to the n minus 1 power. Okay? Same thing here would be function of n equals function of 1 times r to the n minus 1 power. Okay? So far, so good. Let's scroll up a little bit. Okay? If you need to, pause, rewind, listen over what we said, take notes, walk through what we did, make sure it makes sense. Okay, so let's reflect really quickly. The first term of a geometric sequence, okay, f of 1 or 6 in that previous geometric sequence, the first term of a geometric sequence is 81, right? 81. And the common ratio is 1/3. Okay, our common ratio, 1/3. How could you find the fourth term of the sequence? Okay, well, if we used something like this, all we would need to do is write out our explicit rule, and then that's going to give us the answer for that sequence, right? So we're going to evaluate the explicit rule. That's what we're looking for, right? The explicit rule. So how can we find the fourth term? We can evaluate the explicit rule. Okay, and then when we have the explicit rule, then all we need to do is multiply it out. Okay, and our explicit rule will be function of n. Okay, and remember n equals 4. That's what we're looking for here. The fourth term is going to equal 81. That's the one that we started with. 81 times 1/3 to the 4 minus 1 power. Okay, so when we multiply that out, we get the function of n equals 81 times 1/3 times 1/3 times 1/3 times 1/3. Okay, now I know you can do this in your head really quickly. Function of n equals 81 times 1/27. Now, you're thinking, is that right, Ms. Palacios? Well, because our ratio is 1/3, that means the number's getting smaller, so far we're so good, right? 81 times 1 over 27 would be 81 over 27, and that's going to equal 3. So that would be our output. So we know the fourth number of the sequence, if the first one is 81, the fourth number is going to be 3. That would be my answer. Okay? What information do you need to know in order to find the fifth term of a geometric sequence? Okay? So if we're looking at the sequence of numbers, how do we get the fifth term? Well, we could get any term as long as we know the first term and the common ratio. Okay, if you have those two things, you can find anything else because you can write an explicit rule that will help us find any term in a sequence. Okay, last one. 2C, what is the recursive rule for this sequence? All right, remember, recursive rule is a little bit different than explicit rule. In this one, we're just doing the function of n minus 1 times whatever the ratio is. All right, what is the recursive rule for this sequence? F of n equals 5 times 4 to the n minus 1 power. All right, so we're looking at writing it like this. So this is written in our explicit rule form. Okay, it's written like this. In this one, all we're doing is changing the form. Okay, so f of n equals function of 4 minus 1 I'm sorry. The function of 1 is 5, right? So the function of n is going to equal, that's where we take this part, the function of n minus 1 times 4, okay? And this is for any number for n that is greater than or equal to 2, okay? So we're just taking function of n minus 1 times 4. I'll try to make this a little clearer. Equals the function of, all right, n minus 1 times 4, because this is our ratio right here, and our starting point is 5, okay? So you would plug that in to find the rule. All right, and basically that's just taking what we wrote as an explicit rule and putting it as a recursive rule. So we're just changing the format, but it's going to give us the same thing. What this is telling us is the number that we got previously times 4. So the next number in the sequence, 2, would be n minus 1. So 1 minus 1 is 5, right? 5 times 4 would be 20. And then for 2, it would be whatever we got, 2 minus 1, in that section would be 20 times 4, 80 would be the next number in the sequence. Okay, so this one would be 5, 20, 80, 400, and on and on and on. Okay, pause that. We'll go on to example 3. Otherwise, good job.